Hello, Algebra 1A students for Ms. Buchanan. I'm taking a look at your review, making sure you have the right answers. You did all this in class, I believe, but I want to go over the answers. So we're looking at these graphs, and we're going to see which one represents the wording over here. The numbers are kind of all out of order. This is just a review. So number 11. A cup of hot coffee cools down until it reaches room temperature. Which graph best represents the temperature of the coffee? Okay, so it's slowly cool. Coffee, just doesn't all of a sudden. This one right here looks like you had a cup of coffee, you threw it in the freezer, and then pulled it out. That didn't happen. It just cooled down over time and then stayed at that room temperature. So this is going to be the one. Graph B is going to be the one for that one. Okay. This one, Mitch went for a hike. He got halfway up the mountain and realized he had dropped his compass. He turned around and walked back. He found the compass at the point he started the hike. He picked it up. Then he hiked to the top of the mountain. Which graph represents the total distance he hiked? Okay, so total distance. It's not, the total distance that he hiked. So, how much he's hiking. So you have the total distance, he keeps going. Even though he came back, he's still covering, like if he had it on his watch, how many steps he's still getting steps. So he keeps growing and growing and growing. So it just keeps going. So you're going to look at A for that one. Now, if it was which represents the distance, away from, if it said the distance away from the original spot, then, he went away, he came back, and then he hiked to the top of the mountain. So I'm not sure which one, if she's the total distance that he hiked, I would go with A. But if it's just talking about distance in general, distance away from the point of start, so he came back to the start and then he went to the top of the mountain, I would go with B then. Taking a look at these, we're just looking at quadrants for this section. So you'll see, what quadrant these points are in. So let me just show you a couple of them, like -6, -6. So when they're both negative, you're going to be in quadrant 3. Okay, so -6, -6 that's where K is, and that's a quadrant 3. And you use Roman numerals for the quadrants. +6, -5 is going to be down here, and +6, -5 was right here. That's going to be A, and that's a quadrant 4. Let me get the next two to cover the other quadrants. -8 and 6. So -8 and then 6, that's going to be J, and that's going to be quadrant 2. And then this one, 1, 6. So 1, 6, when they're both positive, you're in quadrant 1. And then here you have the other ones. Number 8 is that point at which it's 0, 0, B, that's going to be called the origin. Okay, the ordered pairs for each given point. I have those, and probably should be in parentheses. So you could just take a look at those. Hopefully I didn't make any mistakes. Okay. And then what you had to do is you had to put on these, using these coordinates, use these coordinates to place these letters on the graph, and I have them in red. So -3, 0, I have R right there, -3, 0. -4, -7. -4, -7, I put my P there. -4, -2, I put my W there. 0, 7, 0, 7, it's a y-intercept right there, that's I. -9 + 7, -9 + 7 is a U. -9, -9, -5, -9, -5 is Y. -3, -8, -3, -8, D. And -7, 0. -7, 0 is right there, and I didn't put my letter on it. It's supposed to be an H. Okay. Taking a look at these, or to say whether or not it's a function. Domain and range, she said we're not doing yet, so we'll just hold off on those. But anyways, well, I guess we could say domain. The domain and range on this one would be easy. It's just going to give these. I think we're not doing domain and range. So, anyways, I could do domain and range. Domain is just all the x values, and range is going to be the y values. So, whether or not this is a function, let's look at these first. So, I have 7, 10, -2, 4, and I have -2 again, right? And so this is going to be 8, 15, 3, -7, and 8. So these are my x's, these are my y's. And so I'm going to have, let's go in order, -2, and -2 is twice. Then I have 4, then I have 7, and I have 10. This one goes -7, 3, 8, and 15. Now my -2 goes with 3 and 8. -2 goes with 3 and it goes with 8. And then I have 10, oh, I'm sorry, 4. 4 goes with -7. My 7 goes with 8. And my 10 goes with 15. Okay, and let me see, -7, I need that one to go with 4, yeah, just double check them, 3, 8, okay, so this 8 one, we see going twice. All right, so I just plot these points, and so, actually, these aren't going to fit on here. So I could go maybe if I go by 2s. So this would be 2, 4, this is my x values, these are my y values. So let me do this first one, 7, 8. So 2, 4, 6, 7 would be in the middle there. And if I go up 8, 2, 4, 6, 8. So right about in there. If I'm going by 2s, okay? 10, 15, so 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 12, still doesn't fit, 14, 15 would be like right about in there, 10, 15, -2, 3, -2, and then 3 would be right here if these were by 2s, then I have 4, -7, so 2, 4, and then -7, 2, 4, 6, and 1 would be 7 right there. And then I have -2 and 8, 2, 4, 6, 8. Okay, notice the vertical line test. I have these two hitting each other on a vertical line test. That means, and so I have two x values that are the same. So that's going to be no, it's not a function. Okay? All right, when I do these, so the domain is just going to be all of the x values. So if I go in order, -2, 4, 7, and 10, and my range is going to be -7, 3, 8, and 15. All right, let's go to number 2. Number 2, I have -3 and 8, 12 and 6, -4 and 6, 4 and 5, -2 and 11. Okay, here's my x values, here's my y values. I'm going to go in order, so I'm going to go -4, -3, -2, 4, and 12. I don't have any repeaters. I noticed. So that's going to be yes. I already know that's a function now because I don't have any repeaters in the x values. Okay? And then y, if I go in order, I don't think you necessarily have to go in order. I'm just doing it for the heck of it, I guess. Okay, so -3 goes with 8. 12 went with 6. -4 went with 6. Oh, I didn't have to repeat that. Let me make this one big 6. There we go. It's okay if you have y that repeats. It's going to still be a function. It's when x repeats. That's the problem, okay? 4 goes with 5. And -2 goes with 11, okay? Then you just plot these points. And this one I'm going to go by 2's also because this graph is too small. So I go -3 to 3, and I go 8, 2, 4, 6, 8. Then I'm going to go 12, 6, 2, 4, 6, 8, 10, 12, and then 2, 4, 6. That's if these are by 2's. -4, 6. So 2, 4, 6. And then 4, 5, 2, 4, and then 5. It's going to be 2, 4, 5. And then -2, that's not a dot. I just set my pen down for a second. 2, and then 11. 2, 4, 6, 8, 10, 11 is going to be right there. Notice vertical line test. It's all good. Yes, the domain are just all of the x values in order. These are my x values. -2, 4, 12. And then I have 5, 6, 8, and 11. Remember, I made that mistake. I wrote 2 6s here. Just 1 6 is all you need. Okay, so domain and range we don't have to worry about on this. If it's a function, okay, so we're looking at the vertical line test. So yes, this is a function. I'm not hitting more than 1 point in any vertical line. Any vertical line, I'm not hitting more than 1 point. So yes, that is a function too. This one, boom, no, I'm hitting 2 points in all of my vertical lines. So no, that's not a function. And this one, I'm only hitting 1 point at a time. So yes, that is a function also. Okay, so choose the graph that best represents each situation. Karina is riding a horse on a carousel. Which graph best represents her distance from the center of the ride in a single rotation? So specifically, the distance from the center, she is going to stay the same distance from the center the entire time. So graph B is going to be the one that you want. She's not going to go out and away unless that was some sort of weird ellipse or something, some strange carousel. We're talking about the same distance the whole time that she's riding that carousel. Hopefully this helps, and good luck with the test.